Okay, let's do some proofs. Number 1, cosecant 2x plus cotangent 2x is equal to cotangent of x. So we have to prove this. What I like to do is start by changing everything to sines and coses, right? So I'm speaking the same language across the board here. So cosecant 2x I could say is 1 over sine of 2x. Cotangent 2x I could say is cos 2x over sine 2x. And then cotangent of x you could say is cos x over sine x. And then from there, these two on the left I would add together, so 1 plus cos 2x over sine 2x, and that's equal to cos x over sine x. And already it's starting to look more similar, right? Now on the left-hand side, I can recognize that this thing on top is half of my double angle identity, right? If you remember what the double angle identity looks like, it says cos of 2x equals 2 cos squared x minus 1. Well, if I move that 1 to the other side, then I get 1 plus cos 2x equals 2 cos squared x. Well, this is what I have here, so I can swap it out with this, right? And the reason I want to do that is because I kind of want all the angles the same, right? I want a bunch of x's, not some 2x's and some x's. I need to make this look like this. So I'm going to replace the top with 2 cos squared x, and then that's over sine 2x. Well, I can do the same thing on the bottom, right? Because recall that sine 2x is equal to 2 sine x cos x, right? That's another double angle identity, so I can use that. 2 sine x cos x equals cos x over sine x. Now what's going to happen? The 2's cancel. One of the coses on top cancels with the cos on the bottom. And you're left with cos over sine equals cos over sine. Your left side is equal to your right side. And that's it. Okay, so usually I work on just one side at a time, but for this, it was just a quick one. Wasn't too bad, right? All right, good. Now let's move on to another one. Number 2. Let's say we have cos to the 4 theta minus sine to the 4 theta equals cos 2 theta. How do we prove this? Well, you could say that this is a difference of squares and we could factor it, right? It would be cos squared theta plus sine squared theta multiplied by cos squared theta minus sine squared theta, and that's equal to cos 2 theta. And on the left here, what you notice is that cos squared plus sine squared is equal to 1. So that goes away. It's just equal to 1, right? So on the left I have cos squared minus sine squared. Cos squared theta minus sine squared theta is all I'm left with on the left. And on the right, cos 2 theta, I can swap that out for the double angle identity, which says that's equal to cos squared theta minus sine squared theta, right? That's the double angle identity. Well now, look, I have the same thing on both sides. So my left side is equal to my right side. I'm all done. Not too bad once you figure out what the trick to it is, right? Let's look at another one. Number 3. I have sine of 2x divided by 1 minus cos of 2x. And that's going to equal cotangent of x. Okay, so on the right-hand side, I'll do this one properly. I'll do each side on its own. So right side, I can change that to cos x over sine x. And on my left side, what do I have? Well, on the top, I could change that using the double angle identity. I could say it's 2 sine x cos x, just so I'm only dealing with x. And then on the bottom, I'll do the same thing. You'll have 1 minus cos of 2x. You can swap out for 1 minus 2 sine squared x. And the reason I picked this one is because the 1's are going to cancel, right? So you're left with 2 sine x cos x divided by 1 minus 1. They go away. 1 minus negative 2, that's going to be positive. So you'll get 2 sine squared x on the bottom. Okay, now the 2 on the bottom cancels with the 2 on top. The sine on the top cancels with one of the sines on the bottom. And you're just left with cos x over sine x, which is equal to your right side. Therefore, you're all done. That's your proof. Let's do number 4. We have secant of t equals sine of 2t divided by sine t. And then we're going to subtract cos 2t divided by cos of t. Prove that these are equal to each other. So on the left side, I'm just going to rewrite what I have as 1 over cos of t. And then I really want to work on the right side because it looks like there's more potential here, right? This looks like more of a mess. So I'm going to change sine of 2t using the double angle identity. That's going to become 2 sine t cos t all over sine t, and those sine t's will cancel, minus cos of 2t I can change to 2 cos squared t minus 1 over cos of t. And then if you notice, we can split up the top, right? We can split that whole fraction up. So I have 2 cos t minus 2 cos squared t over cos t plus, because it's minus minus, so plus 1 over cos t, just like that. And the reason I'm doing that is because I want to get 1 over cos t, right? Like on the left, that's what I have. Now, what's this? Well, the cos squared, one of those will cancel out with the cos t on the bottom. So I get 2 cos t minus 2 cos t. Those cancel, and I'm just left with 1 over cos t, which is equal to my left side. And therefore, that's it. I'm done. I got the same thing on both sides. So at this point, let's take a break. Let me give you a couple of rules that are going to help you, or maybe tips. Maybe they're not rules, but things to remember when you're doing these proofs, okay? So what I like to do is I like to change everything to sine x and cos x. So if I have tans, cosecant, secants, cotangents, I like to change them all to sine and cos, okay? And I also like to make the angles equal to x. So if they're 2x or something like that, I'll change those to x's using the double angle identities, right? So that's one thing I'll do. I'll also try to make the form on each side look the same, right? So change forms to look similar. Like if one side has a fraction, then you make the other side a fraction, or if one's not, then the other one's not, right? So an example would be, if they're fractions, or if there's, 2 terms versus 1 term, like whatever it is, try to make them look similar. Like up here in the last example, I have 1 term here and then 2 big fractions being subtracted. So because there's 2 fractions here and I need to get 1 term at the end of the day, I know I'm going to have to either combine them or get rid of those denominators and they're going to cancel. Now, the way we did it was we turned it into 1 over cos t. And then when you start doing the right side, you see, oh, there's a 1 over cos t here. I better try to cancel those other things out. So, so just try to make the forms on either side look more similar to each other. And then I would say look for familiar identities. So look for familiar identities. Like if you see some cos squares and if you see like a cos squared and a sine squared, think, oh, is that a Pythagorean identity? Unless they're subtracted, then maybe it's a double angle identity, right? So you got to look for things that look familiar and then see if there's an identity that's a part of. If you get stuck, try to factor, right? If you look and you can't do anything, like you have nowhere to go, see if you can factor it. And then also, you want to work on the more complex side. You can do a little bit of work on each side. Like all these questions, I've simplified each side a little bit first, but after that, you want to do most of your work on the more complicated side. So if you follow these tips, I think that would give you a better chance at solving these proofs for the most part. Let's try another example. Let's do number 5. Let's say we have cosecant theta times sine theta minus sine squared theta equals cos squared theta. What can I do? Well, on the left, I have 1 over sine theta, that's what cosecant is, times sine theta minus sine squared theta. So I'll actually just say this is my left side. These are going to cancel, and you're left with 1 minus sine squared theta. Well, remember Pythagorean identity, that's equal to cos squared theta, which is equal to my right side, right? And you're all done. So again, look for familiar identities. When I see this, I say that looks familiar, and sure enough it is. It's your Pythagorean identity, right? Or half of it anyway. Cos squared is what it's equal to. Number 6, cotangent x divided by 1 plus cotangent squared x. That's equal to sine x cos x. Okay, what can I do? Well, on the left side, what I really have is cotangent of x, which is cos x over sine x. I'm going to divide the bottom, so I'm going to say divided by 1 plus, and then cotangent squared is cos squared x over sine squared x. So what I have is cos x over sine x divided by, I can combine these together with a common denominator, say sine squared x over sine squared x instead of 1, and then combine it with this, and then what you'll get is just sine squared x plus cos squared x over that. And that's just Pythagorean identity on top, right? Those together just equal 1. So you could say, oh, that's just equal to 1. So I'm dividing by 1 over sine squared x. And you could change that to multiplication and flip it, right? So times sine squared x over 1. Well, one of those sine squared x's on top will cancel with the one on the bottom, and you're just left with cos x sine x, which of course is equal to your right side, and you're all done. Let's do another one, number 7. Let's say you have tan squared beta minus tan squared beta times sine squared beta. That's going to equal sine squared beta. So let's work on the left side. What we have here is, well, first I'm going to factor out a tan squared beta before I simplify things. You'll have 1 minus sine squared beta, like that. Tan squared beta is just equal to sine squared beta over cos squared beta, right? And then from there, what's on the inside of this bracket? Well, from Pythagorean identity, that's just cos squared beta, right? So you get sine squared beta over cos squared beta times cos squared beta, right? Because that's equal to that. These cancel, and you're left with sine squared beta. That's equal to your right side, right? You get the same thing here as here. Okay, one final question. Number 8. 1 over 1 minus cos beta plus 1 over 1 plus cos beta, and that equals 2 cosecant squared beta. So on the right, what I have is 2 over sine squared beta. That's what this really represents, right? You can change it to sine. And now on the left-hand side, I'm going to have, well, I need a common denominator, so I'm going to multiply each of these by each other, right? So I'm going to get 1 minus cos beta times 1 plus cos beta. So I'm multiplying the left fraction by 1 plus cos beta on the top and bottom. So I'm going to get 1 plus cos beta. And over here I'm multiplying by this thing. So I'm going to get 1 minus cos beta. What do I get? Well, let's FOIL the bottom and we'll just simplify the top. So on the top you have 1 plus 1 is 2. And then cos beta minus cos beta, those cancel. So on the top I just have 2 actually. So I'll put that in the middle. On the bottom we FOIL. 1 times 1 is 1. 1 times cos beta, negative cos beta times 1 is minus cos beta. Those are going to cancel. And then minus cos beta times cos beta is minus cos squared beta, just like that. Almost done. On the bottom, 1 minus cos squared beta. Remember Pythagorean identity, that looks familiar. 1 minus cos squared. That's equal to sine squared. And on the top you have 2. That is equal to your right side, right? This and this up here, those are the same. So we have reached our goal. So one more thing I'll say is that when you're going through this process, constantly look at the other side. Remind yourself of what you're trying to get, because some people get here or very close to it and they don't even realize how close they are, right? So remind yourself of what you're trying to get to, okay? And then just keep working, and then sometimes it just kind of solves itself.